Hey, well, thanks for joining us today. My name is Robin Queen. I'm an associate professor of biomedical engineering and mechanics, as well as orthopedic surgery, and a faculty fellow in the Office for the Vice President for Research and Innovation at Virginia Tech. And I'm excited to talk to you guys today a little bit about the work that we do in the lab, and as well within the department. So with that, I just wanted to start with a little bit of a background on me and then again the lab. So I came to Virginia Tech roughly 5 years ago, um, from a department of orthopedic surgery. And so you'll see a large portion of the work that I do is still very much tied into the clinical care of our patient populations. So the Kevin Granada lab is the lab that I direct in the College of Engineering. And our focus is really on understanding injury and then ultimately how do we prevent injury and then what can we do with our either athletes or older adults to allow them to get back to the things that they love to do following whatever type of rehabilitation or surgical intervention that they have. So wanted to talk a little bit about some of the technologies that we use and then walk through a few of the projects that we've done over the past 5 years since I've come to Virginia Tech. So one of the key methods that we use to complete our research is motion capture, or mocap as we call it for short. Most people are more familiar with motion capture from animations in movies or making of video games, and it is the exact same technology that you've seen used in those two applications. We just use it for a different purpose. And for us, that's about assessing the way somebody's moving so that we can begin to understand how to intervene and how to change their movement patterns, either in order to prevent an injury or to help them recover following an injury. And these are just a few examples, again, out of more the animation space, which we do collaborate some across campus with that work as well. So some of the work that we do also branches over into applications in sports and sports performance. I would say that's a minor portion of the work that we do. And really for us, the focus is more on our athletes and how they're performing in order to reduce that injury risk, not so much from a performance perspective. Although, like I said, we are asked to help with that at times. My work sits really at that translational position between the lab and the clinical setting. And it's really where I love to be. I like to be able to see how the work that we do really impacts patients and ultimately their long-term joint health. It is meant to bridge that gap between the two. And for us, when we talk about clinical populations, that can be physical therapy, that could be orthopedics, that can be occupational therapy. It really doesn't, there's not one area specifically in which I focus. So what we want to do is understand the locomotor or movement limitations that exist in these patients, and then how do we restore that function, at least to a level where people can do the things that they love to do. And these are a few examples of some of the orthopedics work that I've been involved in over the years. We've worked with patients who've had hip replacements, knee replacements, ankle replacements, and then also ankle fusions, which is the x-ray over on the side there, with the goal of understanding not just how the joint itself is impacted and how it recovers, but also the implications for the rest of the lower extremity, both on the side that had the surgery as well as the other side, so that we can understand what we need to do from a systems approach in order to restore them back to the level of activity they would like. So as an overview of the research program in the Granada lab, again, a lot of our focus is on translating the work that we do in the lab into the clinical setting. So some of the information that I'm showing you here, the images that are shown here, are early steps in that process. The first picture is part of a clinical trial that we were working on that is just finished about 3 months ago or so, where we were looking at visual and tactile biofeedback in patients who had an anterior cruciate ligament reconstruction. And I'll talk a little bit more about that trial here in a bit. The center picture here is a set of load soles, and I'll talk a little more about those as well. But those are single sensor insoles that we can use to measure the amount of force that is seen underneath the foot as people are doing different activities. And This is one example of that, and this is some hop testing that we were doing, again, in anterior cruciate ligament or ACL reconstructed patients in order to understand how they were landing, both on their surgical leg as well as the other limb. This bottom image is one of our older adult patients walking on an instrumented treadmill. So this instrumented treadmill has two force plates in it that again allow us to understand how they're contacting the ground. And we were doing a visual biofeedback project with those participants in order to normalize or make the load underneath both feet more similar as they were progressing out of therapy and into through the post-operative course. So I talked a lot about the patient population work we do, and I really love that work. I've also had the opportunity since coming to Virginia Tech to work with fantastic collaborators across the college and as well as outside of the college. This is one project I helped out with a little bit when we were looking at the design of energy harvesting backpacks for the military. The goal was to be able to harvest enough energy that they didn't have to carry nearly as many batteries with them. My role in that project was more on the human factor side and determining how much of an impact the backpack was having on the way they were moving and walking. This is a great project that's still ongoing in some of our stroke patients, looking at the development of a multi-sensor system to be able to track recovery and move therapeutic interventions into the home setting. And this was a great project that's getting ready to finish up now, but we were working with colleagues in virtual reality space. In this case, was a sports performance-based project to look at accuracy and precision of the quarterback in throwing a football. And we're beginning to also transition this over into some soccer questions that relate more to the ACL patients. This set of images, again, some of them are similar to the first slide, but just see that we also do a lot of work in incline and decline walking, which is great on our treadmill. And again, with a variety of patient and age patient populations. The one that isn't on here that we've started more recently is some work with young children with cerebral palsy that we're really excited about moving forward with some collaborators up at the Franklin Biomedical Research Institute. I mentioned earlier this idea of the clinical trial that we had, that we've just finished. And the goal of that project was for us to work on neuromuscular retraining. And the idea there is to be able to retrain somebody to be able to land in order to normalize the load that is seen between each foot. So the blue arrows that you see coming up on the screen in these videos is the resultant ground reaction force. So it's the force that the body is placing on the ground, either in a squat or in the landing. And the idea behind this clinical trial was that we would be able to retrain the landing by altering the way that they were squatting. And so the participants in this study were all post-op from an ACL reconstruction. They had to be at least 4 months out from that surgery and able to jump and land to participate. We then had them complete a 6-week intervention program in which they came to see us 2 times a week for 6 weeks. And we performed 2 different types of biofeedback. The one in this image is a visual biofeedback in which they were asked to keep those bars on the screen level within the green boxes that you see there in order to normalize the load on each limb. And the other biofeedback component we did was a tactile biofeedback that pulled them across, or we pulled their knee in towards the center of their body. That's the knee that had surgery, which forced them to put more weight through that limb as they were doing the squatting test. The goal was for them to be able to, one, feel confident in that knee again in terms of what it was able to do, but then also work on the control of the knee in what we call the frontal plane, or looking at them straight on so that it didn't come in. In order to assess whether or not we were successful in this clinical trial, we did a series of jumping and landing tasks and squatting tasks. They were tested before we started the intervention, and then again immediately following the 6-week intervention, and then again 6 weeks following that to look at a retention. And what we found is that we were able to make some changes in their movement patterns, not all of them that we had hoped for. And again, this was a pilot program, so we're working right now to make some modifications to that intervention and hopefully receive some additional funding to try a slightly modified version of this intervention. Again, a lot of our work is trying to translate what we do in the lab out into the clinic. So I just showed you some examples of the 3D motion capture system that we use. And while it's fantastic and we can do a lot of work with it, it's not something that's readily available in the clinic setting. So this work has been happening probably for the last 3 years or so. We've been trying to develop automated tracking from videos that are taken in 2 dimensions. So either from the side or from the front. And then track those markers, again, in an automatic fashion so that we can quickly provide feedback to our clinicians about how somebody's moving. This particular example was in running, and I'll show you one in a few minutes in jumping and landing. So you can see from this video, we were able to eventually develop software that allows us to track the movement of these markers. And the only ones that this system is tracking are the ones on the square pieces of tape. We were comparing that to the 3D motion capture system in order to validate. That's why they have all of the markers on. But we were able to get accurate and reliable information off of the 2D system. This gives us a lot of hope for what we're going to be able to do in the future in terms of translating this in, again, to the clinic or the lab, or into the clinic setting out of the lab. We talked a little bit earlier, or I showed you an image earlier of the load sole, and we do a decent amount of work using the load sole as a means of translating the work into the clinic. So the load sole gives us information that is similar to what we get off of our force plates. It's not exactly the same, but it's similar. It has advantages in that if it's directly within the shoe, it allows us to be able to collect data anywhere at any time. And all we need is a portable device like an iPhone or an iPad in this case, the iPod, or they now have an Android version as well. And we can collect data real time. It can be data logged either onto the insole itself and then downloaded, or collected live real time with the application there. The advantages of that for us is that we don't have to worry about bringing people to us. We can actually go to these patients, to the clinic, the PT clinic, or to their home if we need to begin to understand how they're moving and functioning. We had one study, just as an example of the utility of the load sole, where we collected outdoor running, and we looked at a group of participants who ran 2 miles and then came back another day and ran 4 miles with the hope of understanding side-by-side differences in load across the span of that run. And what you can see here is what we see when we download the load sole data, which doesn't look like much. It looks like a big red square, and underlying that a set of blue lines. If you zoom in on that, what you see is each and every step that participant took over the course of the 2 or the 4 mile run. So it's a huge amount of information for us to begin to look at. You can see when they were slowing down here towards the end, and then if we zoomed back out and looked at the next set, you'd see that they were speeding back up again, most likely coming to an intersection or a curb or something like that. So it gives us a huge advantage over what we can do in the lab setting. The next example I wanted to talk about was the extension of the work that I showed you with running, and this is in jumping and landing. We were able to collect this data, first of all, in the lab, as you see here, looking at just a box jump or a drop vertical jump. It's called both. We collected data with an iPhone and then the GoPro, really to see which one was better in terms of being able to give us the information we wanted at the capture speed that we wanted. And so we were tracking the markers that you can see in this image and validating that, again, up against our motion capture system. We then were able to take the system out of the lab and into the clinic. Oh, sorry. Into the clinic setting, and this was some work done by a fantastic graduate student who graduated in May, and it was the last part of his dissertation work was to collect this data in the clinic setting and to look at the landing kinematics and kinetics in the physical therapy setting in these post-op ACL reconstructed patients. And what we found was that we were able to accurately and reliably collect two-dimensional joint position data, as well as load data. So you can see, if you look carefully, he has the load soles in the shoes while he was completing these tasks in the clinic. Again, huge for us in that we know now we can begin to do this work in other places, and specifically important for us in Southwest Virginia. It means that people don't have to drive an hour to an hour and a half to come to the lab to see us, that we can meet them at a central location and still be able to provide the information that's important for their rehabilitation and recovery. I wanted to take just a minute and talk about some of the other aspects of the work that we do that isn't necessarily directly related to the science. I mean, it is related to our science, but it is more science outreach and engagement work that we're incredibly excited to be a part of. These are just some images from various outreach events, some with younger kids, some with high school and early college students. Just getting them interested and excited about biomechanics, about science in general, about coming to college and engaging in the work that we love so much. I will extend an invitation for anybody who is interested that April 7th and 8th, we're hosting this year's National Biomechanics Day, which is what NBD stands for, virtually due to COVID-19 and the restrictions on large gatherings. So there's a link there to the website that'll be launched later this week or early next week, definitely before April 7th. That contains a lot of information about biomechanics, not just in the Granada lab, but across the College of Engineering and in various labs and departments that are all engaged in this type of biomechanics work. There's some fun virtual reality spaces for you to explore the different lab settings, as well as some videos describing some of the equipment. And for any parents or teachers that happen to be joining us today, there's also some hands-on work that students can participate in as they're learning about biomechanics. I always like to show pictures of the lab. This was actually a year ago, almost exactly a year ago. We participate every year as a lab in the 3.2 to 32. For those that don't know, it's a run in remembrance of the Hokies that we lost on April 16th. Dr. Granada, who the lab is named for, was one of those who was lost during the shootings, and so we do this in honor of him and the others that we lost that day. So this is the lab, at least last year's group. Hopefully in a few weeks we'll have a new set of pictures from this year. We generally like to do this as a team together, and again, the last few years that just hasn't been possible. So did want to share that. And end with saying, for us, this is about getting people back to doing the things that they love to do. These happen to be pictures of my kids because they're also a very important part of my life and what I do day to day. The goal for us always is to get people back playing with their grandkids or gardening or playing sports or going out and skiing or just hanging out with friends in a way that's comfortable and pain-free and allows them again to do the things that they love. So with that, I don't know if there are any questions, but I will stop sharing my screen and open it up for any questions there might be.
Do most people in this field go into physical therapy?
That is a good question. I wouldn't say most. Over the years, the undergrads that have worked in the lab have done a variety of work. Some have stayed in mechanical engineering and have moved on to working on the design of prosthetics, the design of exoskeletons. We've had some that have gone on to physical therapy school. I've had some that have gone to medical school. I have some that love biomechanics so much they end up in grad school and are doing this kind of work long term, and some that end up at companies like Nike and Under Armour and Fitbit and things like that are related fields.
Someone else asked, what kinds of jobs can you expect once you graduate?
Right, similar answer. I mean, with an undergraduate degree and specifically in biomedical engineering, there's a wide range of job opportunities that are out there. Biomedical engineering is a fairly broad field. It could be anything from the work that I do to work in device design and development for medical companies. as well as, again, if there's an interest in a post-undergrad degree in physical therapy and occupational therapy, medical school, or grad school. Obviously, I have a little bias towards that one, but yeah, I think there's a myriad of different options, especially coming out of a biomed program.
The next person asked, what is your favorite study that you've done?
Oh, this is so hard. That is a good question. I think I probably have two. I don't know that I can pick one. So one of them is the last one that I talked about, which is that translational study looking at the development of a 2D system for us to assess landing in the clinic setting. And it's my favorite, or one of my favorites, because it's really kind of the culmination of a lot of years of us trying to get accurate and reliable information that we can give to our clinicians real time. I'd say the second one, which is probably the largest study I've ever done, and we're still working with that data many, many years later, was a study that I worked on at my previous institution, where we collected data on total ankle patients over the span of 5 years for them. So from the time before they had surgery to their follow-up appointments at 1, 2, and 5 years post-op. It was the first large cohort. We had over 600 patients in that study, where we were able to really understand what the long-term outcomes, or sort of I call midterm outcomes, look like following that fairly new joint replacement procedure. And we're beginning to really dig into the basic mechanics of that now. Early on, it was more about the clinical outcomes and how people felt. Now we're beginning to understand what's going on with joint power and how that affects energy recovery and their ability to move about the world without feeling tired and fatigued all the time. And so our hope is to eventually begin a similar to the ACL project, but a clinical trial in post-op rehab for those patients. So that's my favorite because it was so big, I think, and it really taught me a lot about that patient population in a way that we as an orthopedics community at the time really didn't understand.
The next one is, what is the type of course load for this major?
I don't know if I'm the best person to answer that one. I think across engineering, the course loads are fairly consistent. And what I would say is that each department is also slightly different. The best way to understand that is to look at the individual department websites, and they will have a list of the course requirements that are there for the different majors. I will say consistently across any engineering program at Virginia Tech or anywhere else, that it's fairly intense. There's a lot of work to do. I can't speak for the students. I have a lot of fun working with them. I have the pleasure this year piloting an interdisciplinary senior design course, which has been a lot of fun working with students from 4 of the different engineering disciplines, and to hear them talk, it's fairly similar across all of them in terms of the expectations. All students at Virginia Tech in engineering start out in general engineering for the first year, so the coursework is the same across all of the disciplines for that first year, and then you'll go into your discipline-specific work in your second year. Sorry, I don't have specific hour numbers because it is very different depending on department. I guess I'll also say, because I failed to say it when we started, I am at home, which is why I am not in a mask, just so that everybody is aware that I'm standing. Not that you couldn't tell from my lovely background, I'm standing at home in my office. So just so that you all are aware of that. And again, I hope that you all enjoy Engineering Open House and have the opportunity to learn about all of the amazing work that's happening across the college in all of our departments. And if you have other questions, please feel free to reach out. Otherwise, have a great afternoon. And I look forward to hopefully welcoming you guys as Hokies next fall. And we will hopefully chat with you guys soon once you've made decisions. Have a great afternoon.